Hello guys, welcome back to continue the solution of worksheet 6. I think this page number 4. Please, you have to remember when we talk about the continuity of any function or where is the function continuous on the real number, I have to remember the domain or where is the function defined. Okay, here for problem number 5, look here, I have to discuss where is the function defined on the entire number line. Here I told you before I have to write the value of x at which we have different rule. When x less than it, I have rule. When x greater than it, we have another rule. The rule here, when x less than x, 1 over x plus 1. And the rule that I replace in it to find the value of function when x greater than 1, it will be 1 over 3 minus x. But miss here, as you see, these two functions are rational function. This function undefined as the zeros of denominator, which is -1. Here, -1, the function undefined. I have to discuss, is this function continuous on all of the values less than 1? No. Why? Because this function undefined at x equal -1. Otherwise, okay, continuous. So this function continuous here, such that the function, all of the values from -infinity to -1, the function continuous because it will be defined value. The others one, okay, continuous. Here, as you know, what is the zeros here? The function 1 over 3 minus x undefined when x equal what? 3. I have to discuss everything. Where is the function undefined? Where the value at which we have two different rule? Okay, the values of x, we have different rule. I have to write on the number line. Okay, here continuous. Here what? Continuous. But here what? The function undefined. Okay, please here. Miss here, I know here at -1 the function discontinuous. I will write what here? Whole. It will not be included in my interval. It will not be included in my interval. And here we have what? Whole, because the function undefined. The function undefined, so the function discontinuous at 3 and -1. The rest of the real number here 1. I have to discuss the continuity at x equal 1. Look here with me. How? I have to follow the steps. Step number 1, step number 2, step number 3. Because the definition of continuity, limit from right as the limit from left as the value of the function. I have to find f of 1 because I discussed the continuity at number what? 1. I replace in the rule at which we have equal. So it will be 1 over 2. Okay? Limit f of x when x approaches to 1 from left, limit f of x when x approaches to 1 from right. If the limit from left as the limit from right as the value of the function, so the function continuous at this point, that is the definition of continuity. From left, replace here in left because less than, from left to less than, it will be 1 over 2. Okay, 1 over 1 plus 1, it will be 1 over 2. Greater than, it means limit from right, it will be what? 1 over 2. Since the limit from right as the limit from left as the value of the function, so the function continuous at 1, it will be shaded. It will be included, okay, in the interval on which the function continuous. Let's write the continuity. Here, the interval represent this one not included, open, okay? It will be The function continuous on negative infinity, because always we write open bracket at infinity or negative infinity. Negative 1, it will be open because it is not included, and when the value not included, I write open arc. This is called open arc. What else is the function continuous? Here, negative 1, all of the real number here, okay? It will be negative 1, but 1 included, I write closed interval. This, I use this bracket. This means number 1 included in my interval on which the function continuous. What else? All of real number here, it will be what? 1 and 3. Open, because it is continuous as 3. Here infinity, and what is the last one? Open 3 and open interval 3 and infinity. I use this arc referring to the value which not included. I have open circle at it, because the function here discontinuous at negative 1 and discontinuous at 3. Why? Because the function undefined and negative 1, if we replace negative 1 here, it will be undefined. If we replace by 3 here, it will be undefined. So that is the interval on which the function is continuous. Okay, I think it's so easy. Please watch the video many times. I have to discuss where is the function defined or undefined on the whole number line. Okay, thank you. Here for this one, look here. Determine if the function is continuous on the given interval. Here I give you several intervals as you see, and I'd like to discuss this function continuous on which one. To discuss the continuity, I have to find the domain. What is the domain of this function? X not equal the zeros of denominator. When the denominator equals 0, if x equal negative 5. Okay? I told you before, any function continuous on interval if it is continuous on everywhere or at every point in this interval. If the function discontinuous at least one point in this interval, it will be discontinuous. That is open interval 3 and 7, closed interval negative 6 and 4, open interval negative infinity and 0, open interval negative 5, and understand? This means the set of real number between 3 and 7. Between 3 and 7. Here, I have to take the interval which has not negative 5. Why? Because this function continuous everywhere except negative 5. If it contains negative 5, so the function will not be continuous on this interval. Negative 5 included in 3 and 7, remember the number line? No. So the function here is what? Continuous. Understand? Negative 5 here between negative 6 and 4. So this function here, this continuous. Why? Because I have one point in this interval, the function what? Sorry, here. The function discontinuous at one point here in this interval, so it will not be continuous on this interval. Okay, negative 5 included here means yes, it is negative, and this set represents all of the negative number. So the function discontinuous. The function continuous on an interval if it is continuous at every point in this interval. If you have only one value at which the function discontinuous in this interval, the function will not be continuous at it. Here, negative 5 included or not included? It is not included. Open, this open, it means negative 5 not included. So negative 5 at which is this function discontinuous is discontinuous, not included, so here it was continuous. I take that it will be continuous on the interval which doesn't include negative 5. Here, closed, this means included. That is the meaning, closed, that is called the closed bracket. Negative 5 included. So since negative 5 here and at negative 5, this function discontinuous, so the function discontinuous on this interval. Clear? Negative 5 here also included. So here the function this what? I'm sorry. Discontinuous because it has 1. Because this function discontinuous at negative 5. Clear? I hope you understand. Watch the video several times to understand. Any function, that is definition, continuous on an interval, if it is continuous at every point. If we have only one point in the interval, what is the meaning of interval? Set of points. It means from 3 to 7 on the number line here. Okay, this function doesn't has negative 5 or negative 5 not included in this interval, which means 3 and 7. Interval represents set of real number on the number line. Okay. Here the next question. Please focus. I think this one is so trivial. Focus with me. I told you what is the mean of continuity. It means the function has the function. Its graph has no interruption. Like what? It has no hole, has no jump, has no unbounded behavior, has no liquid gap. Okay? At any of this part of the graph, in the graph of the function discontinuous. Here at 4, as you see, we have here what? Hole. So the function discontinuous. Here we have jump. Interruption, cut. We have cut in the or broken part in the curve of the function. Discontinuous at x equal what? 1. Since the function here limit does not exist. Here we have what? Jump. Here we have hole. We have what? Hole. I think it's easy. Revise the definition of the continuity in the previous video. Here as you see, I have hole. At negative 2, I have hole at 2, and I have unbounded behavior at what? 0. So this function discontinuous at negative 2 to 0. The answer, it will be C. Here as you see in the graph, we have hole at x equal 6. So the function discontinuous. I'm sorry, I did a big mistake. Do you know what? Since I solved like this exercise in the session, I record the session, I thought I read the head of the question with you, but I have to read it again. Here, find all points where the function is discontinuous. Understand? So I have to take the values of x at which we have hole, or we have jump, we have gap, we have unbounded behavior. The graph, as you see, we don't have any of these cases, so none. I don't have any values of x at which is this function discontinuous. By the same way, here in this case, I don't have any one of my cases at which the function discontinuous. For the last one, Miss, I know I don't have hole, I don't have gap, I don't have jump, but I have unbounded behavior. I have discontinuity. I have here, as you see, interruption. So we have at x equal what? 3. Discontinuity. Here it's so clear. At negative 2 and 2 we have hole, we have hole. Do you have any other cases? No. At x equal negative 2 and x equal 2. Clear? Hole. In this case, as you see, no, I don't have a continuous, but here at 0, it's so clear, miss, I have interruption here. This interruption or cut has been done in the graph of the function, as you see, or unbounded behavior. The limit does not exist. That is the second condition in the definition of continuity. Okay, sorry, I'm so sorry. Sorry, I didn't concentrate. So it will be at what? At x equal what? 0. Okay? Now, it's so trivial and you solved all of them, but I'd like to give you the answer of each question. Is f continuous at f of 1? That is at x equal 1. At x equal 1 here, as you see. But at it we have what? Gap. We have gap or we have interruption. So, no, it is not continuous. Okay? If is the f continuous at f of 3, that is at x equals 3, as you see. We have what? At x equals 3, we have jump. We have jump. The limit from right, not like limit from left. So the function discontinuous. No, it is no. Okay? Here for this one, is f continuous at 0? At 0, I think I don't have any interruption. Here I don't have gap, I don't have hole, I don't have anything. So we will write yes. Okay? For this one, please remember, is f continuous on interval -2? Look here, I'm here. From -2 to what? 4. From here to here. Okay, from this one to this one. Is a function continuous? Not. A function is continuous on an interval if it is continuous at every point in the interval. In this case, do you have any interruption has been done in the curve of the function? Yes, so clear. At 2. Okay, at what? 2. We have jump and we have gap like this one. The limit does not exist and the also the function, okay, does not exist and the value of the function different, sure. So we say no because at 2 we have an interruption. If the function, so it is continuous, no, it doesn't continuous, okay? Okay, let's see the next question. Yes, this question is very, very important. Look here. I ask you to find numbers A, B, or C, or K, whatever variable which included in the problem. Here, as you see the problem in this problem, we have the variable what? K. He asks you to find such that this function is continuous everywhere. This means this function continuous on all of the real number, this one continuous on all of the real number. So I'll use the definition of the continuity at this point -1. That is my mechanism. This means this function continuous also at -1. What is the condition at which this function continuous? It means limit. That is the definition of f of x when x approaches to -1 from left as limit. That is definition when the function continuous at any value, at any point. When the limit from right at this point, which is -1, as the limit of f of x when x approaches to -1 from right as f of -1. Definition, study this definition. -1 can be any value. I can write -1, 2, 3. That is according to the given in our problem. To find the value of k, I have to get equation in k. Okay? By solving this equation, I find k. I use the equation of this one. I have to find equation here, limit from right as the limit from left. To find limit from left, it will be, I have to replace here 3 multiply -1 plus 8. The limit from right. Limit from right. Left. Limit from left and limit from right. Here from right, replace in this rule because right, it means x greater than. -1 multiply, replace x by -1. It will be -1 multiply k, it will be -k plus 4. The equation which I'm searching for it. How we get it this one? By replace in left and replace in the right, okay? It will be here -1, you can use the calculator, it will be 5 equal -k plus 4. How to solve this equation? Switch here the value, opposite sign k. Here opposite sign, it will be negative 5 plus 4, it will be negative 1. That is the value of k, negative 1. Try to search for how we get equation in k. I used limit from right as the limit from left. That is my way to solve like this problem, okay? Please watch the video many times and prepare all of their questions, okay, for the next session. Thank you and have a nice day. Bye-bye.